All right, good morning, everyone. Welcome to another great day of being a tiger. Today we're going to start into Chapter 10, Section 1. This chapter is going to be all about circles and different segments and lines that go through them or touch them and all that kind of stuff. Today we're just going to talk about some of the basic vocabulary and the most basic formulas of circles, pretty much all things that you've heard before, especially from the formulas point of view, but just want to make sure we're all on the same plane before we go any further. So the first thing is a radius. If there's more than one, we call them a radii, but the radius of a circle is the distance from the center of a circle to any point along the outside. So CD, segment CD is a radius, segment CE is a radius, segment CF is a radius. Since all three of those are radii, all three of them would have to be congruent. They'd have to be the exact same length. Any radius is the exact same length as any other radius of the same circle. A chord is any segment that has both of its endpoints on the circle. So AB is a chord, because here's A on the circle, B on the circle. DE is also a chord, because D and E, both the endpoints, are on the circle. CF is not a chord because C, one of the endpoints, is not on the circle. CF is just a radius, so it is not a chord. A diameter is a specific chord that goes through the center. So diameter is any chord that goes through the center, so it touches the circle with both endpoints, and in the middle of it is the center of the circle. A diameter is made up of two radii. DC and EC are both radii, so DE is a diameter. All things you know. All right. To name the circle and identify a radius, we can call this circle E. You will often see this named as circle E. I usually write out the word because I'm not very good at drawing that picture of a circle, but it's a circle with a dot in the middle. We name a circle by the center of the circle. To name a radius, we could say a radius is segment BE, or we could call a radius segment DE. BE and DE are both radii of that circle. Those are the only two options. All right. To identify a chord is any segment that has both endpoints on the circle, so WZ is a chord. There are other chords, but the other chords are also diameters. So XZ, segment XZ, is a chord and a diameter, and so is WY. WY, also a chord and a diameter. So all three of these are chords, but only these two are diameters because only those two go through the center of the circle, point Q. All right, we would call this circle F, and just one radius. There are many options, but I will just go with segment FN. Could do segment AF or segment FT. All right, which one of these is not a chord? In order to be a chord, you need both endpoints on the circle. So this is a chord, this is a chord, this is a chord, this is a chord. But FN is not a chord because F, that endpoint, is not on the circle. All right. We talked about what a radius and a diameter is. As I said before, a diameter is really just two radii that are going in a straight line. So that means that a radius is half of a diameter, or if you know what the diameter is, divide it by 2. Divide it by 2 or multiply it by half to find the radius. And if you know what the radius is, you can just multiply it by 2 to find the diameter of the circle. This is all stuff you guys have done before. So right here, they tell us RT is 21. RT is a diameter. QV is a radius. So we just do 21 divided by 2, and we get 10.5 centimeters. Okay, any radius is half of any diameter. Right here, just a little bit of some other pairs and things we talk about circles. For two circles to be congruent, remember, to be congruent means they have to have the exact same size and shape. In order to be congruent, they have to have the same radius. Okay, if their radii are congruent, then they are congruent circles. So any two circles that have the same radius are congruent. All circles are similar. All circles are going to have that same, well, round shape, so they'll all have the same shape. The only difference is that they will, some might be bigger or smaller than others depending on how large the radius is. And then this one here is probably a new vocabulary word. You might not have used this before in previous math classes. It is concentric circles. Concentric circles. If you look right there in the middle of that word, concentric, you see what looks like center. And that is exactly what they are. They are two circles that have the same center, that lie in the same plane. So both of those circles there have A as their center. All right, so the diameter of circle X, a diameter of circle X is 22, a diameter of circle Y is 16, and they tell us that this right here is 5 units. If a diameter of X is 22, then I know from here to here is half of that, that is 11. If this part here is 5, I can find that this one is 6, that's 5. All right, and they tell us that the diameter, again, of this circle is 16, so that means from here to here, just a radius is half of that, so 8. If this is 5, and the whole thing is 8, that means that's only 3 long. They want us to find the distance from X to Y. 6 plus 5 plus 3. 6 plus 5 is 11. 11 plus 3 is 14. And since it's just in units, this would also just be in units. All right, same type of an example here. The diameters of our circles are 4, 9, and 18 in that order. 4, 9, 18. And they want us to find from A to C. So if the diameter of D is 4, that means from here to here is just 2. If we go on circle B, this one right here, the entire diameter from here to here, from here to here, the entire diameter of that circle is 9 inches, and they just want AC, which is from here to here, so it's that entire diameter minus these two, so 9 minus 2 would be 7. All right. Here we go. The circumference of a circle. Circumference is basically the same as a perimeter. We just can't call it a perimeter because perimeter means it has to do with straight lines. But other than that, it's the exact same idea. It's the distance around the outside of a circle. The circumference is equal to pi times the diameter, or if we don't know the diameter, we can think of it as the diameter can be replaced by 2 times the radius. So this is 2 times the radius times pi. And you all know what pi is. It's about 3.14. Everyone, well, many people's favorite irrational number, not mine. So, a series of crop circles was discovered in Alberta, Canada on September 4th, 1999. The largest of the 3 circles had a radius of 30 feet. Find its circumference. Circumference is equal to 2 pi r. So our circumference is 2 times pi times 30. 2 times 30 is 60. Okay, sometimes we'll ask you for an exact answer and you'll just leave it right there, 60 pi. Other than that, we can type it in our calculator to get a better idea. 60, and here's my pi button, 60 times pi, 60 times 3.1415, you know, goes on forever, is about 188.50, rounding off. And since everything was in feet, that is also in feet. So this would be the exact answer, and this would be rounded. Depends on what the directions ask you for. The Unisphere is a giant steel globe that sits in wherever this is. It has a diameter of 120 feet. Find its circumference. Circumference is equal to pi. This time it's a diameter, so we don't need to multiply it by 2. Pi times diameter, so 120 pi. These are all rounded off, so 120 times pi gives me just about 377 feet. There it is. Just typing it in, rounding off. All right. Find the diameter and radius. So once we find the diameter, we can just divide by 2, or if we find the radius first, we'll multiply by 2, of a circle to the nearest hundredth if the circumference of the circle is 65.4 feet. So circumference is equal to 2 pi r So I'm going to plug 65.4 in, is equal to 2 times pi times r. I'm going to do 65.4 divided by 2, and I get 32.7 is equal to pi times my radius. Divide that by pi, and I find out that my radius is right around to the nearest hundredth, so that's 2 decimal, 10.41 feet. To find the diameter, it asks for both, multiply by 2. The diameter is 20.82 feet. Ask for both radius and diameter, so we'll give them both radius and diameter. All right. Find the radius of a circle to the nearest hundredth if it's circumference. So again, circumference is equal to 2 pi r. So we do 16.8 divided by 2 divided by pi, and it rounds to 2.67. 2.67. Since everything else was in meters, so is this. All right, for our last type of example, just throwing in a little bit here of review of everyone's second favorite triangle, at least my second favorite. We have a 90-degree right triangle, and we know that this side and this side are both a radius, so these two are congruent. So that means this has to be a 45, 45, 90 triangle. The hypotenuse is 3 times the square root of 2. If you know the hypotenuse, to find the leg, you divide by the square root of 2. So each of those radii is 3. We want to find the circumference. Circumference is 2 pi r. So 2 pi times 3, it is 6 pi. Since this says exact, I leave it there. I do not type it in my calculator. If I were to type in times 3.14 or even 3.14159 or as far as you can go out, it's not going to be exact. So we just leave it as 6 pi when they ask for an exact answer. Okay, same thing here. Again, we have 10 for this side, and we know that this side's the same. This side's also 10. Here's our right angle. If this is a radius and that's a radius, those are congruent. This is a 45, 45, 90 triangle. I'm sorry, these two are congruent to each other. The two radius are congruent, not the two radii are congruent, not necessarily, well, it can't be congruent to that as well. So these two are congruent to each other. We know the hypotenuse. To find the leg, we divide by the square root of 2. So we multiply top and bottom by that square root of 2, and we get 10 radical 2 over square root of 4. Square root of 4 is 2, so 10 radical 2 over 2. 10 divided by 2 goes down to 5. So 5 square root of 2. The radius, any radius of that circle, is 5 times the square root of 2. So to find the circumference, circumference is equal to 2 pi r. Circumference is equal to 2 pi times 5 radical 2. 2 times 5 is 10 radical 2, and we have a pi. 10 radical 2 pi. There it is, exact. It says exact, so we don't round this off as a decimal, and we don't round that off as a decimal. There it is. All right, here's your homework. Pause the video here or get this off of Canvas, write it down, and the rest of the time is yours to work. Have a great day. See y'all later.